Hello everyone, welcome to the lecture. Myself Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is equivalence of regular expressions and automata. We need to show that for every regular expressions, there is an automaton that accepts the same language. So, regular expressions will represent the regular languages. So, these regular languages can be accepted by the finite automata. So, from regular expressions, we can get regular languages. From regular expression, we can construct finite automata. Then, pick the most powerful automaton type is epsilon NFA. For every regular expressions, we can construct epsilon NFA, that is non-deterministic finite automata with epsilon moves. Epsilon means empty string. So, without any input symbol, we can get the transition from one state to next state in the epsilon NFA. Next, and we need to show that for every automaton there is a regular expression defining its language. So, for every automaton there is a regular expression. So, we can construct automaton from regular expression. From automaton also we can construct regular expressions. We can construct finite automata from regular expression. Also we can convert finite automata into regular expressions. So, pick the most restrictive type is DFA. Next, converting a regular expression to an epsilon NFA, that is NFA with epsilon moves. Proof is an induction on the number of operators. Here we are using the operators plus concatenation and closure star in the regular expressions. Plus means union, concatenation, then star, clean a star. Basis for equivalence of regular expression to automata. See, for a symbol A, the equivalent to finite automata is this. So, input is A, the symbol is A, the automaton is initial state to final state with the transition label A. So, this is Q0, this is Q1. From Q0 to Q1 there is a transition, with the label A. So, we are defining the transition function for input A on state Q0. Next, if the symbol is epsilon, that is empty string, epsilon means empty string, zero occurrences of symbols, that means there is a initial state, as well as final state, or next state. I can go to next state with epsilon. That means without any input, without consuming any input, we can move from one state to other state. If the symbol, that is pi, that means null set, epsilon is not equal to null set. These two are different. Epsilon is empty string, set with empty string, pi is null set. So, that there is an initial state, there is a final state, but there is no transition from initial state to final state for null. I will draw here. So, this is initial state, this is final state, there is no transition. Next, induction 1, regular expression to epsilon NFA for union case. E1 is a regular expression, E2 is another regular expression, then E1 plus E2 is also a regular expression. The equivalent NFA with epsilon moves, epsilon NFA is this. How we can draw this? For example, E1 is equals to A, E2 is equals to B. So, for E1 the automaton is like this, initial state to final state with label A. For E2 there is a finite automata like this, initial state to final state with label B. If you take E1 plus E2, that is A plus B, that means A plus B. We have choice, either we can get the matching string that will matches either A or B. For this we can draw the NFA for this. For constructing finite automata for E1 plus E2, we need to create a new final state and we need to take a new initial state, so that this is no more initial state, this is no more initial state. Now this becomes new initial state, from new initial state to old initial state for this finite automata with epsilon move. That means there is empty move, epsilon move, like this, from new initial state to this epsilon move. Then this is no more final state, this is no more final state, from this state to new final state there is epsilon move, So, we have two paths from initial state to final state, either we can move this path or we can take this path going to final state, that is union case, either A or B. So, that is given in this diagram. This is new initial state, this is new final state, this is new final state. From new initial state to old initial state there is epsilon move, like that here are epsilon moves. From old final state to new final state there is epsilon move, here also epsilon move, like that. This is the finite automata with epsilon moves for union case, E1 union E2. Next, induction 2 for concatenation. See, E1 E2 concatenation, E1 is equals to A, E2 is a regular expression is equals to B, E1 followed by E2 is a regular expression, that is AB is a concatenation. For E1 the finite automata is this is initial state, this is final state with label A. For E2 this is for E1, for E2 this is initial state, this is final state, B, this is initial state. For E2 this is the finite automata. If you want to concatenate E1 followed by E2, concatenation of E1 E2, we can get E1 followed by E2. So, that for that we need to construct NFA for E1 E2. For E1 this is the finite automata, from this is the old final state, now this is no more final state, this is initial state for E2, this is no more initial state for E2 now, and there is a epsilon move from final state of E1 to initial state of E2 with epsilon move. Now, this is the concatenation NFA for epsilon, NFA with epsilon move for concatenation. See this is the finite automata for E1, this is the finite automata for E2. We can concatenate this by using epsilon move. Next, closure. See, if E is a regular expression, E star is also a regular expression. For example, E is equals to A, then E star is equals to A star. So, for A star we need to construct the finite automata, clean A closure. This is called clean A closure. So, A star is a regular expression, will give the language containing epsilon, 0 occurrences of A, 1 occurrence of A, 2 occurrences of A, 3 occurrences of A, 4 occurrences of A, and so on up to infinity. So, for this we need to construct the finite automata. For A, this is the finite automata. This is the finite automata. 1 occurrence, but 0 occurrence should be there. 0 occurrence means epsilon. Without consuming any input, we need to go to final state. How can you go to final state without consuming any input? So, that we need, this is the NFA for A, but for epsilon also we need to construct. For that, we need to take a new final state, and a new initial state. From new initial state to final state, there is epsilon move, that is without consuming an input I can go to final state. So, for epsilon there is a move, for A there is a NFA, for AA two times repetition, so that I can get 2 A's by reading this like that. From this state without consuming any input I can go to previous state, there I can read second A and come back to here. If you want to 3 A's, I can read 3 A's from here, from this state to this state I can read A, going back to previous state with the epsilon move, second time I can read A and going back to previous state with epsilon move, and third time I will read A, and so on. You can read any number of A's, so that we can connect this state to this state with epsilon move. This is no more final state, and also this is no more initial state, this is new initial state. I can connect this with the epsilon move. Like that, clean a closure. For clean a closure, this is the NFA. The same is depicted in this diagram. This is epsilon move, this is A. For example, this is the E. For example, E is equals to A. I can read any number of A's by using this loop with epsilon move. I can read as many number of A's as possible. Then, if there is no symbol epsilon only there, I can go to final state with epsilon move. So, if there is one A, I can go from initial state to here with epsilon move, there I can read A, then from this state to I can go to final state. If I want to read 2 A's from initial state, I can go to this state, there I can read A. So, after reading A, I want to read one more A, going back to previous state with null move, then read second A and going to final state. Like that, you can read any number of A's. This is the NFA with epsilon move for E star. Thank you.